So now we're going to finish this worksheet from section 20.2. And the next page on the worksheet, we've got 5 monosaccharides, and it's asking us to classify them as D or L, but we're going to do some bonus stuff on this also. We're not just going to do the classification. We'll start with that though. So for classifying the monosaccharides as D versus L, what you're going to do is go to the bottom of the drawing. So we're going to go here, and then we're going to go one up from that. So we're always looking one up from the very bottom. And then we're going to ask ourselves when we are here, where's the OH group? Is it on the left side or is it on the right side? When it's on the right side, this guy is D. If it's on the left side, it's L. Let's try that again. We're going to go down to the bottom. We're going to look at one up from the bottom. This guy is on the left side, so this is an L. And again, OH is on the left side, so it's an L. Go to the bottom of the carbon chain, and one up from there, our OH group is on the right side, so this is D. Go to the bottom of the carbon chain, one up, OH is on the left side, so this is an L. Bottom of the carbon chain, one up, OH is on the right, and so this is a D. So that's pretty simple. Let's, what else? The other thing I want to do with this is let's practice finding the names for these guys. Let's practice finding the name for this one right here, and we'll find the name for this one right here. So when we're being asked to find the name, then that means we need to go to one of these tables that I linked on your Canvas site. You first of all need to find the correct table. Are you looking at an aldose or are you looking at a ketose? Where's the double bond? And so that first one that I said we're going to name, that's an aldose. So this is the correct table that we want to use. And then you need to find the right number of carbon atoms and find that row on this table. We have 3 carbon atoms, so we're all the way at the very top. There's only one option here. This is D-glyceraldehyde. D-glyceraldehyde. Let's name our other guy, this guy over here. So this one is a ketose because it has a carbon-oxygen double bond on carbon number 2. So that means we're going to go to the other table. This is our ketose table, and this one isn't as easy to look at, I don't think, at least. So we have to find the correct number of carbon atoms. That molecule that you're looking at that we're naming has 1, 2, 3, 4, 5, 6 carbon atoms, so we're going to go all the way down to the bottom. And then you need to, whoa, what did I do? Then you need to find the correct pattern of your OHs going from underneath the carbon-oxygen double bond and down. So our OHs are left, right, right. Left, right, right is the 4B structure. Oh, I zoomed in. And to get the name of that, 4B, we have to look down at the very bottom of the screen where they give us the relationship, or it's like the answer key down here. So 4B, it says that it is D fructose. That's kind of confusing. So the name first and then in parentheses 4B. So this is D fructose. D fructose. So the other thing that I want to practice on this worksheet, the other bonus thing that I want to do is practice drawing the enantiomers of these molecules, because that's another thing that you're going to do on sapling. It's asking you not to draw them, but to find the enantiomers of these molecules. Remember, enantiomer is mirror image. And so if we are drawing, we're going to do the enantiomer for this guy right here. If we're drawing the mirror image or the enantiomer of this molecule, the easiest way to do it is to just straight up draw the mirror image. So imagine that the mirror is right here and just draw everything mirrored. And you can even go this far, CH2OH, like, see, I've reversed the whole thing. Now, recognize that when you're looking at these problems on sapling, the only thing that really matters in terms of is it on the left or is it on the right are the carbons that are on the horizontal bonds, or the things that are attached to the horizontal bonds. So on sapling, the stuff down here at the bottom of the chain, it might be drawn mirrored or it might not be drawn mirrored. And the same is true for the stuff up here at the top. So you could draw it like this, that's fine, but you could also choose to not mirror the very bottom, and you could choose to not mirror the up top also. So maybe you would see it like this. And again, when we're drawing the enantiomer, the only thing that really matters is that you mirror the horizontal bonds, these guys right here. We're mirroring the chiral carbons, and only the chiral carbons. That's what it means to draw the enantiomer. So let's try that again over here. Let's draw the enantiomer of this guy. So if we're doing it ourselves and we're trying to keep things as simple as possible, our instinct is going to be to straight up mirror the whole thing like this, because that is going to help us get our answer correct. But keep in mind that the only thing that really needs to be mirrored is the chiral carbon, this guy right here, this guy right here. So if you're looking at sapling and this structure that you drew is not an option, look for an option where the top and the bottom carbons were not mirrored, because technically they don't have to be. They are not chiral. And also this guy right here, which is also not chiral, is not mirrored. So it could look like this. Again, the most important part is that you're mirroring the chiral carbon, this guy right here.